All right, let's liven this up a little bit here. We got a hootenanny. We're not really sure. I thought when I picked this crew, somebody would know how to play a musical instrument. Turns out that's not the case, so.
I play the piano, but you can't wheel a baby grand up here.
I was hoping banjo, but then I heard that might not be good either, so. Especially you, Louisiana,
I know,
come on.
I know. Dustin, I was kind of looking at Dustin saying, you for sure should play something. I mean, you live on the...
I was going to bring a harmonica, but things happen.
All right, we're going to get started here. Really the goal today is to be able to hear from practitioners in the field how they are utilizing dehumidifiers, the challenges they're having, how they're successful, and then also at the very end we're going to discuss how to sell it. Because at the end of the day, if you can't sell it, it doesn't even matter, right? We're not even there. So go here. My name is Nikki Krueger. I am the marketing director for Santa Fe Dehumidifiers. I've been in the industry about 20 years in indoor air quality overall. The last 14 years have been focusing on ventilation and dehumidification. If you don't know, Ultra Air and Santa Fe are the same brand. We took Ultra Air whole house ventilating and rebranded it to Santa Fe. It's not another dehumidifier manufacturer in the market. It's the same. So really focusing on education. That's our goal. First of all, let's educate and then get it installed correctly. So go ahead, Tim.
I am Tim Stasio. I am what you get when you order Jennery Garcia on Wish.com. I have been in heating and air conditioning my entire adult life. Started out with commercial industrial, eventually got into residential, started my own business, sold that business, and then moved to the beach, and now kind of do consulting, design, and service call every now and then. So.
All right, Dustin.
I'm Dustin Cole. I'm from Lake Charles, Louisiana, HVAC contractor, a little over 20 years in the business. That's what I do. I like fixing things, solving problems, and taking a deeper look at the overall system, not just the box, the whole system. That's all I got.
Morning, Chris Conway. I'm not an HVAC guy. I'm a HERS rater, so maybe a little out of my league here with all you sharp guys. 15 years, multifamily, light commercial, single family. I'm dominant. My dominant is kind of low-income, affordable multifamily housing. So I live in that world. I hope there are a few of you in here, so I have somebody to talk to in here. Yeah, you can talk to me. Thanks, Dustin. Appreciate it.
Chris Hughes. I work for the Energy Conservatory. My history has been HVAC contractor all of my life. I just went to work for the manufacturer 2.5 years ago. And I just wanted to really deep dive in building science, how pressure and flow come together, and all that kind of fun jazz. It's a heck of a rabbit hole, and I felt like coming from the HVAC side, I was a good person to maybe help relate building science to the HVAC community. So that's my mission in life. That's what I'm working on, and yeah.
So, if you might have noticed on the program, Jennery was supposed to be joining us today. But he could not make it. But all you need to know about Jennery is he's the GOAT. So That's it, right? You have anything to add to that, Chris?
Jennery is a special human being. If you're not following Comfort Dynamics on his Facebook group, you should, because he posts a lot of content. And Jennery's the kind of person that when you ever heard the expression "a dog on a bone"? He's relentless, and he will not let it go until he figures it out. He's probably the most driven person when it comes to that I've ever met in my life.
Yeah. Data. We just did a case study together. There's a link at the very end to that with Jennery, but the amount of testing and how particular he is and to detail is incredible. So he is a huge asset to our industry. All right, today we're going to talk about basically dehumidifiers 101. Just to make sure that we're all on the same page with terminology and how dehumidifiers and air conditioning kind of work overall, installs, how to size, ventilation, and how to sell. These are basically the questions a lot of times that all of us get. And so we thought we'd do a little bit of deep dive into each one of these. So first of all, a whole house ventilating dehumidifier integrates with the HVAC system. When I say that, I mean that it utilizes the ductwork to distribute the air. But it will dehumidify the entire home independent of the air conditioner. You can ventilate, meaning we can do positive pressure ventilation into the home, and then it has a MERV 13 filter in it. So when we are ventilating, we are filtering out the contaminants from the outside, but also when we're not ventilating, we are filtering the air that's from the inside of the house through the whole dehumidifier. So what's a dehumidifier? Basically, I can't remember who came up yesterday and asked me, he's like, how do you explain a dehumidifier? I'm like, it's an air conditioner in the box. Basically, all the components are in that box. But what we're focusing on is getting a very cold coil to remove as much water as possible. So our coils, you know, the coils on the AC system typically will get down to, 49 degrees about or so? About that? And we're getting down, we can get down almost to freezing on our coils. So we are focusing on getting that coil as cold as possible without going into defrost and removing as much water as possible. All right, so why do homes need dedicated dehumidification? Comfort, health, and property protection. Those are the three things. I will say comfort is probably the #1 reason that we will hear from customers that there's a complaint, right? And they think it's their AC. Something's wrong with their AC. Maybe their AC isn't big enough. I'm uncomfortable. They get up at night. They start cranking down that thermostat. It's not because they're uncomfortable from a temperature. It's typically a humidity issue. Health, we all have heard about indoor air quality. That's the big focus, especially since COVID. And then property protection, if you're, seeing some microbial growth either in the house, maybe it's a closed attic, maybe it's a crawl space, crop protection is a big one. Partial and no load times of the year. We are seeing this more and more the tighter our houses get, right? We're not having those peak load conditions in our homes and getting those run times that we used to in order to be able to remove the maximum amount of water. And then shoulder seasons times, overnight times when the AC is not running. First, the most important is once people move in that house, you can't control them. I will tell you, this gentleman right here, Chris Conway, who is my husband, likes the thermostat much different set point than I do. So we're constantly battling, the thermostat wars in our own house. So how people are going to live, you never know. If any of you deal in senior housing, I've got into a lot of multifamily senior housing where it's set at 80 degrees and there's microbial growth and the maintenance staff comes in and sets it at 74 and you have very unhappy people when you do that. So how people live, you can design it perfect, you can install it perfect, but how they live in that house, you can't control. And the goal is to get to that manual J, right? 75, 50, but all bets are off once people move in. And it is the only way to ensure that 50% relative humidity. It's the only way when you have a dehumidifier that's taking water out of the air and it's going down the drain, it is the only way that you can ensure that you can be at that 50% relative humidity all the time.
By battling, she means I'm losing a lot. That's what battling means.
I was going to add to that, you know how to handle that situation that I'm sure a bunch of you have probably addressed before and pulled this card, but you got to put in that non-communicating thermostat on the wall with no wires. You know what I mean? Yeah. And they change the temperature and they're like, it's still cold in here. And you're like, did you change the stat? I did. Well, don't look at me.
No, they changed the number and they're like, see, it feels better now. Like, sure.
No, I keep my stats hidden.
The best part is now we can log in remotely and we can change the temperature remotely.
No, I'm talking about fake thermostat.
No. I'm
I
talking
don't know
about
if you caught what I was
faking the
laying down.
entire. No, I got you. But I'm talking about faking the entire temperature. You can do an offset from like remotely on trade
Yeah.
diagnostics.
So Brian wrote an article a couple years ago.
Thanks for the tip, boys.
It's rather big brother of you, though.
Brian wrote an article a couple years ago about all the things that can contribute to high humidity in the home. So, you've got construction drying with, if you're working in new construction, it could be 3 to 5 years, especially with how wet our wood is that we're currently constructing with in homes. So we have a lot of water already in the building just from construction. If you're building on slab, a lot of water from a slab. So lots of wood. Seasonal temperature swings, we've got, here we are in the morning, right? It's cool, then we get to the afternoon and we're warm. We've got a lot of temperature swings going on where we're not running at those peak load conditions or potentially even enough to be running with the variable speed enough. Daily temperature swings. A lot of people don't understand that typically the higher the SEER of the AC system, the less water it removes. So I've got a diagram here to show how that works, but when it's a high SEER, you're focusing on energy efficiency getting to a temperature set point. You're not looking at the energy efficiency of addressing the sensible and the latent together. So it is getting to that temperature set point as quickly as possible. High dew points outside, usually that's going to be your spring and fall. If you look at your design conditions for your manual J, that design temp is going to be very different than the ASHRAE humidity guide, which typically, or dew point guide, which usually is typically about 10 degrees cooler than your design temp for your manual J. So I think Atlanta used to be, the design temp was 93, and the ASHRAE humidity, or what is it called?
There it is.
There it is. The dehumidification value is 10 degrees less than what the design temp is. So that's hard to design for in our manual Js.
It's also important to say that in most cases, the dew point stays the same.
Exactly.
So you'll have the same dew point, lower temperature. So it's just a higher risk of condensation, higher risk of moisture.
Yep.
Oh, in a lot of cases, the peak dehumidification settings or the outdoor conditions, dew point is higher but sensible where the dry bulb temperature is lower. So you got two things working against you. It's a little bit cooler outside, so your AC is going to run less, but it's wetter outside. So now you have to somehow remove more moisture with less AC runtime. And there's just not a solution for that without something supplemental.
So again, people generate moisture, and you can't control people. So our good friend Kimberly Llewellyn over here put this chart together, and it shows when we're at that humidity, the humid partial loads annual frequency of several cities on there. And I know it's small and hard to see, but what's great about this is that it illustrates even down to, I think, Phoenix is on there, and people are like, how is Phoenix on there? But when I first started working for Thermostor, I had somebody from Phoenix call me to want to buy a dehumidifier, and I'm like, oh, you've got the wrong company here. You need a humidifier. And they're like, oh, you don't understand monsoon season, which I never really thought about. But so here you can see that, Miami, I can't even read that. What is that, 4,000? I think I've read this enough, 4,000 some hours of the year that we're at partial load conditions with a dew point greater than 55 in Miami. And so we're all over the, a lot of places in the Northeast. We got the Mid-Atlantic and the South and the Southeast on here. But if we're not running at peak loads, we're probably not maximizing our dehumidification. And when you run your manual J, and you are designing to size that system, what percentage of the year does that system run at that peak load design condition?
1%.
1%. of the time,
Maybe.
approximately.
Maybe.
So, how are you going to control the humidity when you're outside of that 1% peak time air conditioning runtime load? That's challenging.
VRF. No.
What'd you say?
VRF.
Oh, I just say oversize and just go for it.
Somebody's got to make money.
So the sensible heat factor, I get called a lot to look at plans, or people ask me questions because they've got a customer that has a humidity issue, and there's a lot of questions that I ask. I'm never going to tell you this, you call me and say, I got a problem, and I'm going to say, oh, here's a dehumidifier, what's the square footage, here's what you need. There's a lot of factors that go into understanding what's going on in that home and if the dehumidifier is going to be successful. So one of the questions that I'm going to ask you is what the sensible heat factor or the sensible heat ratio is of your AC equipment. And really that means how effective is it at dehumidifying when it is running. And that's important because if we look at this here, and I remember when I said the higher the SEER, usually the less water removal. So I can't even, but we've got about a 2 3/4 ton system there that is a sensible heat factor of, 0.6 something? 0.62. So when that's running, it's really effective at removing moisture. 62% of the BTUs are focused on sensible, and the other 38% are focused on water removal. So when that's running, it's doing a really good job. The other one is a half-ton mini split. And what's that at 96? 96% of the BTUs are focused on cooling, and 4% are focused on removing water. So if you're installing ductless mini split systems, you really need to think about how you're going to add dehumidification, supplemental dehumidification into that design as well.
While also being able to do ventilation. It's kind of a double whammy on that.
Yep, double whammy. Double whammy. All right, so we're going to turn it over to the panel here. Install is always the questions we get, right? Like, especially for retrofit, I've got to go in, because to be honest with you, dehumidifiers are used very little in new construction. Unless it's a semi-custom or custom builder that gets it, production builders do not want to put these in homes. So we get called in, you get called in after the fact to fix the problem, and that's the most challenging time, but that's our world, is retrofitting dehumidifiers. So this is our recommended install. If you're not aware, Thermistore, Santa Fe, is a brand of the company Thermistore. Ken Gehring, who's 84 years old, invented these dehumidifiers back in the mid-90s. If you are on a forum called HVAC Talk, he's known as Teddy Bear on there. And at 84 years old, that's where he spends his days, is on HVAC Talk. I think he's got 12,000 and some posts on there. People who have problems, contractors, go on there and say, I've got this house, what do I do? And usually he's going to give you a list of questions, and he'll be the first to tell you when a dehumidifier is not going to fix that problem. But this is the recommended install that he came up with. And the reason that this is our recommended, it's the most energy efficient way to install a dehumidifier. So when you install it this way, you do not have to run the fan on the HVAC system in order to distribute the air. Now, does it get installed this way? Most of the time, dedicated return to
I don't think you could
supply?
always do that way.
It's hard to get a dedicated return sometimes. Sometimes it's just simply not constructible. But when you can get a dedicated return, then you're taking that much, you're giving yourself back that a little bit more static pressure to apply it to the supply side, as long as you're not running an 80-foot return. But just try to make your returns as least restrictive as possible. If that's a dedicated return, great. If you have to pull from the return that's already there, make sure the return is not a high static return.
Well, that, and you're probably going to need to look at it because you're going to have a derated performance out of that dehumidifier.
You gotta talk louder.
I'm sorry. All right. If you do that, then you need to take a look at your performance data
Yes.
of your dehumidifier because it is going to reduce the capacity of it.
Yep, it will.
Not huge, but it will. Enough to consider.
I look at this a little bit different, as a HERS rater. I said multifamily, but we do lots of, small home, passive houses, that stuff like that. I'm always looking for space. Like when I look at that, I start freaking out because I got a box that I got to put in a little tiny low-income affordable housing apartment that's 500 square feet, and they didn't have enough room for the HVAC system to begin with, much less a dehu. So in new construction, it's all about space. I fight like crazy to try to get you HVAC boys and gals to have a spot to put this in if there's a problem in the future. Where are you going to put this thing? Are you going to, where we start looking for stuff is, can we do a drop ceiling? Can we do it maybe over a washer and dryer? Do we have enough headroom inside the closet where you can almost hang one? So when I look at this, that's what I look at. I look at, is there space to do an optimal install? And if there isn't, I have to fight like crazy to get the architect to understand why this is important potentially in the future. And because you can't control the tenants and the people who live in there. And in a retrofit situation, it's and for those that work in apartments, is you're trying to find every nook and cranny you can to try to put something in, which I think on the next slide might have like an end wall. But it's all about space to try to get the optimal install. So I don't look at the D rate and everything, but.
If it's going to be quick, go ahead. I'm going to go full nerd.
Oh, I'm just saying, fortunately, the Santa Fe's, yes, they do discharge out the ends, but you can flip a panel and it can discharge out the top. So that saves you like 10, 12 inches sometimes when you don't have it. So you do have that option with the Santa Fe's.
I may regret this, but I'm going to go for it.
You're sitting close to me, remember that.
I see that fresh air duct, that's kind of just like, it's not an afterthought, but kind of, it's like, whatever. It's just there, add it if you want to, no big deal, right? How many of you, raise the hands, would absolutely put outdoor air into that dehum if you install it? Show of hands. Okay, how many of you people think, I'm not going to go there, that's going to put more strain on my unit, don't want to deal with it, and you don't tie in the outside air, okay? So, yes, it's good to ventilate, but what you're also doing when you bring in outside air is you can change the neutral pressure plane. And I know that's getting way deep into like, ooh, we're getting nerdy here, but if you change the neutral pressure plane, you can change the amount of infiltration that's happening on the house, which means you have less moisture load in the house because you're kind of building pressure in the house. And to go even a little bit more nerdy, you got to have a tight enough house to move the neutral pressure plane.
So before you go too much more on that and lose anybody, just real quick, what is the neutral pressure plane?
That is the point inside the house where, this gets in the stack effect, where you have flow that goes up through the house from a temper differential between the inside of the house and outside of the house. Temperature drives pressure, pressure drives flow, okay? So if you have a temperature difference, you get flow. If you have a hole in the bottom of the house and a hole in the top of the house, and you have temperature differential, you're going to get stack effect. And you can have stack effect or reverse stack effect, depending on the temperature inside the house versus outside the house, right? The neutral pressure plane is right in the middle of that, right? And it changes up or down depending on how much infiltration you have. There's a lot of factors to it. But what I'm getting at is adding mechanical fresh air ventilation to your install is a good thing. As the house gets tighter, it's even a greater thing. And there comes a point where like you don't need as much as you would think. And you can actually calculate and figure that out. Like there's a process for that. All right, who wants to take a break?
Who's got questions?
To add a little bit more to it, you also have vapor pressure driving doors.
Yep.
Why do you have to be so nerdy?
Doug, you should have had my seat.
So any questions? Yep, go ahead, Matt.
Do you just throw the ventilation function on just any house, regardless of knowing how tight it is? I mean, to me, when I'm thinking of ventilation, do we need ventilation? You know?
Good question. So I'm going to recap the question. To get to this point, he's saying, how much ventilation do you need, right?
Or do you just put it on any house?
Or do you just put it on any house? So ASHRAE 62.2 has a calculator for it. I think you can go to RedCalc. RedCalc has a worksheet for it. And I actually wrote it down because I'll forget it, but it's square foot times 0.01 plus 7.5 CFM per person, or per bedroom plus 1 is the formula. So like that's where it comes from, of how much ventilation you want to throw in the house.
Don't forget the infiltration credit.
And
Well,
well,
yeah, don't use the infiltration credit.
Full nerd.
But yes,
Yeah, don't use the credit.
yes, you can throw ventilation on any home. It's how much you throw at it. And it's important to remember, it doesn't matter how leaky the house is as it pertains to ventilation. The ventilation is for the people. It's not for the house. It's just as a byproduct, we are able to move the neutral pressure plane depending on the tightness of the house, which can help out. Does that make sense?
I don't like
I can barely hear you
using
on
the
the mic.
infiltration credit just because I don't like the idea of ventilating my house with air coming from a crawl space or an attic or a garage. And so yes, the house is leaky, and yes, some of your fresh air coming in the house will come through those spaces, but the more mechanical ventilation you can bring in, control, treat, filter, dry, is only going to make that situation better. The problem is with a lot of ventilation strategies on even programs like Energy Star. You think Energy Star would be a program, okay, we're going to do things the right way, and they totally allow you to ventilate using fart fans. Where are you pulling that air from? So again, the more we can treat that air before we bring it into the house and control it, the better it is for the occupant.
Source control
in Florida,
fans.
where
Source
do you
control
think
fans.
your infiltration mostly comes from in the summer? Do you think it comes through the crack of the front door, or do you think it mostly comes from the cam lights? Who thinks it comes from the cam lights? Show of hands. Who do you think most of it comes from the front of the crack in the front door? Show of hands. So in the summertime, when you're keeping your house cold, right, your infiltration's mostly going to come from the top down, more than likely. That's why we say seal the lid, right? And that is some really, really hot, humid air. Not to mention, Nikki, you were talking about IEQ, it's dirty. Right? You've got all this insulation, right? Let's say you got an open vented attic. Do you really want to be having air moving through fibrous insulation and then coming through the cam light and pouring into the house? And
It's
you've
a
got
filter.
100 or 200 CFM of that? Like, that's not what you want to breathe.
No, of course
But
not.
if you ventilate,
Yeah.
you can stop a lot of that from coming in. And then the air, you're stopping that infiltration coming in from the ceiling.
Yeah, we're talking a lot about single family, but in multifamily, 85% of your air is coming from your stinky neighbor. And if you don't have a stinky neighbor, then you're probably the stinky neighbor. Keep that in mind when you're trying to figure that out too. But yeah, ASHRAE 62.2, that's kind of the go-to to kind of figure out a good baseline. And then you got to worry about distribution and all that. But if you guys do work in multifamily, that's a kicker, because they're not getting much from the outside typically. They're getting it all from their neighbor. Yeah.
So one thing I want to point out on here, because we often get calls that in tech support that the dehumidifier isn't running correctly, and usually what we see is the backdraft damper is either not installed, or it's installed so close to that main HVAC supply that it can't overcome the pressure of that air and actually open up. So that backdraft damper is very important on that supply side, because we don't want air going back down. Now, also going in at that 45-degree angle is important. Now, if you've looked at our manuals in the past, and I've been involved in marketing, for a long time, and I will say that our manuals were embarrassing. We had that coming in at a 90. I mean, we weren't looking at duct stuff at all. And then as I got more into building science and taking ACA courses and going back and looking at these manuals and just hanging my head, so embarrassed that we were putting stuff out there like that. So we're now making sure that we're working with industry experts to get this stuff as accurate as possible. But I think for this, again, you don't have to run the fan on the air handler when you install it this way. I would say if you are working in tight, high-performance homes, that we could potentially create an uncomfortable situation because a dehumidifier is an air conditioner in a box, and our heat is not being discharged outside. The heat is being discharged into the living space. So if there are concerns that that first drop is over the lazy boy in the living room, we should be running that fan on the HVAC system when the dehumidifier is running, so we get better mixing of that air before it's delivered.
Couple of points with that. When who here has heard of manual D? Please, everybody raise your hand. Please. Okay. So when two air streams crash into each other at a 90-degree angle, that's not good. And so if you can make one merge into the other with how you're ducting that with the 45, you can move a lot more air through that dehumidifier. Another thing about the backdraft damper, make sure your installers haven't put 4-inch screws through it where the backdraft damper just kind of hits it and doesn't do anything. Ask me how I know.
I'll tell you a fun story. I learned a lesson on a dehum that I put on a house. It was tied to an inverter system. And I used like a gravity damper. I went there. I wasn't using motorized dampers at the time. And the homeowner called me. He goes, there's this weird noise coming from it, and I don't know what it is. I go there, everything's fine. I'm like, oh, here we go, you know. But I actually went back one day and caught it. And what it was is the inverter system had ramped down low enough of a speed that where the gravity damper was going boom, 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 boom. It was slapping, open and close, the weirdest thing. So I would encourage people, if you're when you do the backdraft damper strategy, I don't think you can beat going electronic.
So back to the ventilation thing. How much ventilation can you move through one of these boxes?
Ventilation is one of the topics that we're going to get to.
Okay.
Yeah, yeah.
All right.
Thanks for reading that presentation before we submitted it.
You're welcome.
I'm sure we're going to show other things. One thing, first off, we're going to have to get the marketing people to draw a better 45. Because I was today years old whenever I learned that was 45. But don't dump it into the return.
We're going to get to that too.
Okay, all right, I'm staying in my lane.
Yep, we're going to get
Great
to
job
that
reading
too.
the presentation.
Apparently, I was the only one that read the slides.
I sit next to her every day. I should probably read the slide.
All right, anything else on this install? I mean, this is optimal. Yep, go ahead.
Yeah, optimal, yes, but like the practicality is like some REs and stuff, you got three, hopefully a 4-foot one, and they're already kind of, optimal is good. Realistically, that's it for that's what it is. And I mean, a lot of times you have to go that 90 degree to get to the airflow.
I had to do it in my house too.
Repeat it.
So I want to recap your question.
Yeah.
You say you have an air handler. Was it in a closet or in an attic?
Predominantly in the closet and gas heat markets.
Gas heat market, closet install, plenum goes up, and you have limited access.
You've got usually horizontal, you've got very limited space in the attic already.
Okay, limited space. Do you have access to get to the branch runs with anything?
Not a lot of them. Newer construction, they're filling the attic bigger and everything, but a lot of retrofits. You've got what space you've got, and that's it.
So
Retrofit's tough.
it is. For my house,
We have a space set up as a
I mean, you could. I mean, as you reiterate rules, you can do this.
You've got really hard space.
I'm having a hard time picturing the install.
I think what he's saying, he's got a vertical unit, coil sitting on top of it, 4-foot plenum going in, horizontal. It's horizontal in the attic. Wait,
You've already got, a cluttered attic system, jobs, and short runs, so you've got like very limited space to actually integrate this template, but it's
Like a rancher, you're talking about a house on slab, closet install goes up, very, very low pitch
no, he's saying
roof.
it's horizontal. Yeah.
No, like it's the closet unit, but then the ductwork's in the attic, and it's a
No,
tight
he's saying
attic.
it's like horizontal.
Forget the closet.
Yeah.
Closet. There's no closets in the house.
I mean, I did hear closet. I'm with you. I don't know where we got off
Something.
that.
I mean, there's a closet here that he wants to come out of, or I don't know.
So is it that there's not enough space in the attic, or there's not enough space on the unit? 'Cause I mean, it's two different things. If there's not enough space on the,
Yeah.
sure,
Sorry.
Oh, you're
right,
Ductwork's up there pre-existing. You've got a lot of your rooms are already kind of stuff.
yeah.
Kind of free at the middle of the ductwork. So you've got whatever space you have on that, you'll have a nice trunk line.
Do you have 8 inches?
Everything is just range ducts that are already on the supply line.
Yeah.
You got a limited amount of space where you can tie in a supply duct from your dehumidifier. So you've got to go in really close to the coil, or and you got to be careful doing that because then you're shooting your air strings directly into a duct on the other side of that funnel. Always going against the airflow. So you've got so many design considerations that are factored in, like optical installation. Like, yeah, it'd be great if I had a 10-foot, trunk and I could pop that thing in and then it can flash and stuff. But we've got to be careful where we put that so we're not throwing it into one room and we get a good mix and
Yeah. I mean,
increase the heat load, try to fix one thing and create another issue.
mixing is always a concern for everybody, and I know that it's a thing. It happens. It's something to consider in the install, but I don't think it's something that should hold you back from doing it. Because if it happens, and that really gets into like the pressure loss of each one of those fittings. What is your duct takeoff? What is the pressure on that? How big is your plenum? It's a whole other area where a lot of people don't even look at that. In most cases, most plenums, in most markets, I don't know where you're at, but they're fairly oversized. Like if you're screwing that thing to fit the coil, put it right at it. It's going to be a very low pressure drop, and mix it in. And if you're having mixing issues, wire in a relay to turn the fan on its lowest possible speed. Now any modern equipment, it's all going to be variable speed, whether that's a constant torque or whatever. But just set it for the lowest possible that you can, and that should alleviate a lot of your mixing issues. It may not. You may kick yourself around a little bit. But the alternative is no ventilation and mold, or lack of comfort. So they're just going to keep on driving it down. We're talking about fixing comfort with the potential of maybe having a lack of comfort. I'm going to take my...
The problem with the fan thing is you have to use it. So you do that right after the cooling cycle and like re-evaporate and all that.
Re-evaporation, yeah.
You got a dehumidifier, but you're adding moisture, so like now you're just wasting energy. Is it enough to overcome it, or is the customer going to have to feel that discomfort long enough to negate the discomfort?
I mean, no one's going to deny re-evaporation. But,
So, he's in Houston, so to me, in Houston, hopefully we're running enough AC that we are satisfying the moisture load, right? Like, Ken Gehring, Teddy Bear would say, AC's king, Hughes queen. If the AC is running, we want it set up to remove as much moisture as possible. And then if it's not satisfied, then hopefully the dehumidifier come on. But what we see is typically air conditioning and dehumidification aren't running together. And if we're getting the good AC run times, which that's what we got to be focused on first and foremost. Yes, we're going in to fix problems, but one of those problems is making sure that the AC is set up. If we're running a warmer coil on the AC, can we get a colder coil on that AC and get some more water out when it is running? Is it as energy efficient? Nope. But, having to add a dehumidifier on isn't always the answer either until we get everything set up to where the dehumidifier is going to be successful. So tying in, obviously is an issue, but if we can get that AC going, and, the dehumidifier, unless you're in a tight house, really tight house, the dehumidifier is going to be those shoulder seasons when we shouldn't be fighting the air conditioning as much and overnight times.
So your concern is valid. Really short trunk, not a lot of space, right? And yeah, mixing is a problem. I've tried that one time, and all the hot air came out of one vent in the master bedroom. He wasn't happy. So what do we learn from that? That sometimes when we sell a dehumidifier, we need to sell some duct modifications so that can be successful. So maybe you only have an 8-foot of duct and you have branches coming off immediately after the coil, maybe you move those branches back so you get time. So we just don't plug and play a dehumidifier. We have to think about those things, and you're forward thinking for doing that. But sometimes duct modifications is part of the package.
I'd sell them a closet.
Build a closet. That's it.
Fixes everything.
So I deal with the same problem you got in Austin. You know, it happens all the time. God knows what we do. So sometimes we have to get the courage to sell the duct modification. Takes out an aisle movement, and I think Chris was going to bring it up. Is why don't you just branch off and put another duct in the common area? That would take care of the problem. You have to.
Well, you know, another interesting concept is what's the model number? The MD33.
Oh, the in-wall dehumidifier.
The in-wall dehum. Why even worry about trying to get it in there, tie it in if the moisture load's not super heavy?
Successfully in some certain applications, but then you have to worry about your condensate management and the electrical and everything.
Yep.
Yeah, those are better installed on a 2x6 wall because they're completely hidden. In a 2x4 wall, the butt's going to be sticking out into the room behind it. And they make heat, so not every application is perfect for that, too.
Yep.
The great thing about that, though, is it does generate heat, but you can put it as close to the ceiling as possible.
Yep.
And then you usually, where water vapor is going to collect anyways, water vapor is lighter than air, and usually people aren't going to feel the heat up there. And so, you know, if we can get, and I think Matt was saying this, and, you know, giving it its own ductwork, one thing that we're seeing more and more is, you know, if we can pull a dedicated return, and then if we've got a bolted ceiling or something like that we can get to and just put that dehumidified air. Now, this isn't a ventilation strategy necessarily because we're not, you know, getting fresh air to bedrooms and that sort of thing, but getting that dehumidified air at that vaulted ceiling point where potentially water vapor is collecting anyways, then that sometimes is a solution also.
And ceiling fans.
Yep, ceiling fans.
Ceiling fans correct a lot of design problems with a house. And like when I design a house for a client, the ceiling fan is normally part of my strategy. We have a conversation about pick you out one that's energy efficient and it's pretty, but that's going to be part of your strategy to get good distribution. And it doesn't take much. It just takes this thing going about 30 RPM and it just mixes that warm, dry air. It just distributes around the house.
That's Wes. Thank you, Wes.
Thanks, Wes.
Thanks,
You
Wes.
got a fan.
We got a fan, not a fan.
He's all about the closets, I'm about the ceiling fans.
In a DHU presentation, so.
Yeah.
You guys need to read the slide deck. It says DU.
Good questions, though.
You're on it. I mean, he's exactly right. You're doing more than just rolling in and putting in a DHU. I mean, you're trying to sell a whole strategy. And so the more familiar you can get with the elements to help the ultimate comfort goal, that's just going to make you stronger, you know. That's what I've done a lot of my education on, is all the tangential things that go along with that. And that seems to work well, because the last thing you want to do is start making a homeowner more pissed off than they were before trying to solve an issue. Yeah.
That's why I try to play devil's advocate with it. Like, it seems like, oh, we've run across all the most complicated crap out there, all the money goes and everything.
Yeah.
I try to find a way to do it too, because I mean, not always it's like,
Right.
that's a mixed budget, I want to be able to help everybody provide the best.
But someone with a fixed budget, you don't want to give them a solution that's going to cost you more headaches, where now you have to own that problem, and they're constant. You've solved one problem, created another. You haven't done anything. So I totally get what you're saying. Yeah.
So if we don't have ductwork, we're seeing a lot more ductless mini-split homes, or maybe we've got high static systems that we're having challenges integrating with. In our manual, you will see if we don't have a bolted ceiling, but we've got to give this dehumidifier its own ductwork, and we're using ductless mini-split heads. We want to get hopefully around 3 supplies, and we want them to as close to those ductless mini-split heads as possible. or we use the in-wall dehumidifier in that application. Have you run into ductless mini split?
Yeah, so I just finished up a design on a house on the water in Wilmington, North Carolina, and the basement, so we already know we're gonna have moisture issues. It's a walkout basement out in the water, strike two, and they got ductless mini splits in each bedroom, oversized ductless mini splits, strike three. So the dehumidifier is supplying air directly above the intake of the ductless mini split. So yes, it's going to be throwing warm air on it, but that mini split immediately sees that and pulls it in, takes care of it. So that's the strategy that you end up having to do with ductless mini splits. And ductless mini splits do not dehumidify that well.
Yes, Kimberly?
I got a comment here. Not from some
Uh-oh.
splits.
Uh-oh. You set off Kimberly.
Only for the right application. So this application that has just been described, where you've got a ductless mini split in a bedroom, you're almost guaranteed to have an oversized system, just like you said. And that 0.96 is a 6,000 B2H humid species system, and our competitors' specs look pretty much the same. However, there are a number of ductless mini splits, different models, larger sizes, that have SHFs that are 0.7, 0.68. So it's really important to look at the specifications, look at the expanded performance data. Don't assume a mini split can't. Dehumidifier has no latent capacity. Some of them do, some of them don't.
But what does that ductless mini split do when it's not running at full speed? When it backs off, because you guys don't publish that when it backs off what the SHF is. So how do we know for the other 99% of the summer?
Measure quick.
We're on the same side of this table. That's why I worked on activator loss revision, and that was my lane to basically put it into code to require that latent capacity at our partial operating conditions. So
Yeah.
the answer to your question is you're running a warmer coil, which means that your SHF is going up. So the latent capacity is not going to be handled as well in your partial load conditions.
Right.
This is not a don't get a dehumidifier.
Yep.
My point is just don't make these super broad strokes. We should always be looking at the expanded performance data and the actual specifications of the systems. And yes, we need more expanded performance data, which is something I'm working on.
All right, thank you. We've got a
Yep,
question
Matt?
right here.
How important is the return location versus, the supplies in a split situation? Just discuss that. How important?
I just want to recap the question. Yeah, this gentleman's, because I want people to be able to hear.
Yeah,
Yeah.
we can't hear the question, so we do need to repeat
Yeah,
it.
he's saying how important is the return location of the dehumidifier? Did I get that right? Okay. Dustin.
In a mini split application or just in general?
Like in the scenario that Nikki described, you have a house with many splits. We know we're going to supply to the rooms. They're having comfort issues. Right now, we're describing just the one return. We're not going to be pulling any return air from those rooms at all. That's not a problem. We're just going to be supplying dry, hot air.
Well, your supply air is what's going to push air back to your returns. What you don't want is rooms that are pressurized, right? Because then you could be leaking air to outside or leaking air back to main return and you don't know, right? So if you get a house tight enough and you don't have barriers of supply air pushing that air back to your return, the return can kind of go anywhere, right? Because it's all going to be mixed and pulled back in. Ideally, you'd want it in a central main area. That way all the air from everywhere gets mixed and pulled in, but ideally that's what you want anyway in the design.
Is there benefit to that even in like this ducted systems from pulling your return from the return if you have multiple returns, not just a central return, that way you're getting return from multiple places to the dehumidifier and then obviously dumping it to the supply versus a dedicated return somewhere all the way around.
Are you saying would it be more beneficial to pull return from the return of the air conditioner versus doing a dedicated return? I would, it all depends on resistance, right? So the dehum works against a certain amount of resistance. The more resistance you put it against, The more inefficient it becomes, the less flow it's going to move, the less water it's going to remove, and so you pay more to run it. So really it comes down to static pressure. What's it working against? If the returns are at a lot of static pressure, I wouldn't tap into them. I'd run a dedicated return to increase my efficiency. That's what Tim was talking about earlier. So I think it would literally come down to the manual design of that equipment, and then how did it test out when commissioned. And if the return is super, super, super low, then tie into it if you want to. No problem there. But if it's got resistance, you're only, you know, putting a little bit of damper on your now dehum install.
When you're looking at these jobs, let's say you go to an estimate for a dehumidifier, you should be taking static pressure on the main system. Because again, we may be doing duct modifications. We may need to get that static pressure down if we can't run a dedicated return to supply. That may be your only choice. Well, if you're running 0.6 static on your return duct, not a great place to tap in for a dehumidifier. You're going to have to, again, include that duct modification. If that's not possible, then you may have to run a dedicated return. Which one is going to give you more airflow?
I like the idea, and I've done it, and I'll tell you why I do like it. Because when I was a contractor, I hated having to have people keep up with filters. Sorry, Nikki. But like, I hated being like, got to get this filter, you got to get that filter. So if I could throw in a super large April Air filter, and then I have my return ducts huge, and that April Air can filtrate my air before it gets to my A coil of my air conditioner, and my coil of my dehum, and I get a 2-for-1 in that, then that's what I want to do.
But if you're ventilating, you got to filter that air before it comes in the dehu,
well,
or else you got
different,
leaves and
it just depends
bird
on the
feathers
design
on there.
strategy.
Yeah. Pick up one of these trifolds.
We're going to get to
We
that.
are?
We're going to get to that. Again, did anybody look at the presentation?
No.
I knew this would come back and bite me
You
by
guys
making
all approved it.
Yeah, it looked good.
The email was, it looks good.
I just have a picture of
And it did.
I have a picture of a closet right
For the
here.
nanosecond I looked at it.
Just like the return and talking about the static in your application as well, you have to check it. It's not an option. Because if you don't, it may never work. Supply, return, all of it. You look at the budget that you have on the HVAC system and make a decision. If at all possible, I prefer dedicated returns. It's just less likely to cause a performance issue on the HVAC or the dehumidifier.
And as close to the unit as possible.
And I can run them independently from each other. I don't have to run them in tandem.
Right.
All right, we return to return.
Don't do
Pass.
Oh, go ahead.
I had a client that wanted to use an Ultra 120, and we went through the worksheet on connecting ductwork. He wasn't willing to go beyond what he wanted, so we're stuck with the equipment and the static pressure we have. We can't run the air handler blower and the dehumidifier at the same time because static won't allow the dehumidifier to do anything. So I call Thermistore and they said dump it in the return.
Yep,
The solution.
that's sometimes the only solution. I mean, do we love it? Is it in our manual? It's in the manual, but there's a lot of caution Will Robinson in there as well when you do that. You have no choice sometimes, but we got to make sure if you're going to do it, it's going to be set up correctly.
I mean, that goes with anything that we do, though. Like, every application is going to be different, and it's going to be a fight, and you can't make it work everywhere without doing major modifications that they may or may not be able to afford.
Yeah.
So you have to get really creative and just accept that sometimes good enough is good enough. It's not the perfect world. It's not where I want to be at. It's not going to be the most energy efficient. Fun fact, latent heat removal is never efficient. But it's the necessary evil. You got to do it. And so you do what you have to do.
The DEH 3000 can disable one when the other runs. So that's a simple control way to make
That's
sure
a
they don't
super
run
sexy
together.
controller too. You're going to want to use that.
From 1987.
I'll also pass on that. But and it's also important to remember throughout all this, like we keep on talking about it, running with the HVAC. It shouldn't.
It shouldn't.
It's the same argument about like, oh, the sensible heat that we're going to add back to it. Who cares? I don't care about that in March. In August I do, but it shouldn't be running. If we're doing our job designing and commissioning our HVAC systems in general and as a whole, I'm not talking about the mistakes of yesteryears. Going forward, there isn't a high static issue. We could tie in. I still don't want to do it, but you could. The system is capable of handling the latent heat. Now, there's a war on latent heat. It's all about the efficiency game. And so it's only going to probably get worse, but we do have people like Kimberly back there that's going to just fight tooth and nail to make things do better. But unfortunately, as we go towards energy efficiency, you are going to consistently lose your latent capacity. This is going to be something you will have to do. It's not an option in the future, unless we come out with some really cool stuff that Michael Hausch makes.
It's funny you said there's a war on sensible heat. I want to know when's the war start on latent heat? When are we going to start that war?
It's starting, and everybody needs to like voice your experience, and we've got to stop chasing SEER.
Yep.
Got to stop chasing the SEER bump.
Is that what happens if you increase SEER, you're going to decrease your latent capacity. That's how it works.
Yeah.
A bigger heat exchanger, which means that your coils are going to run more. In order to get that sensible, that's what that SEER rating is actually only representing, the sensible. So, yeah, use your forums, talk to ACA, find your lobbyists, like use your experience. So we need a war on latent.
So this install, if you live in Florida, with the Florida building code, you only have 2 install options. That's a dedicated return to supply or supply to supply. You cannot use return to return, and you can't pull from the return and go into the supply for the Florida building code. Now, the reason, and I think, do I have this up here? The Hvac, Florida Solar Energy, did a study in 2018 and basically said that a return to return is the most inefficient and ineffective way to install the dehumidifier, because we're heating the coils of the AC system, which means less latent removal from the AC system. Plus, when that AC system shuts off, then the dehu comes on, then we're gonna blow all that water back into the living space. So will you hear Thermistor potentially have to recommend that? There's a chance, if that's our only option. But if we can do something else by looking at the ductwork and our configuration and getting it in there so it is set up some other way, then that's really the way to go.
And their fans can overcome static pressure. Not all dehumidifier manufacturers are built the same. Some of them have really weeny little blowers in there. And that's why they sort of have to do that, because they can't overcome positive duct static pressure. They just can't push against it. They publish their data, send this information, and it's just a better quality unit.
Now, does a stronger fan come with some negatives? Absolutely. Is there a chance that you are going to hear that dehumidifier because there's a stronger fan? Yep. It's a sound of comfort, that's right. But, we hear like it's too loud, we need to be quieter. Well, we can troubleshoot to make the unit actual quieter, but if it's because of the fan, you're going to have to decide, is that CFM important, or not locating it in the attic over a bedroom? Can we figure out a different way somewhere else to put it, or in the crawl space?
Adding flex duct from that unit to the other system attenuates a lot of that.
That helps.
So important, and it is in our manuals, but again.
Can you say that again, Nikki?
So adding, when you're going to tie into rigid duct, make sure when you're coming off the dehu that you do use I think we say 10 to 12 inches or something in the manual. I guess I got to read it. But flex duct on there before you tie into the rigid, because that will minimize noise quite a bit of the unit.
And hanging it with something soft too, like not using threaded rod. Some of us really like using threaded rod. We come from a commercial world. Looks great. It also carries a lot of vibration. So I started either using their hanging kit, which is like kind of like a rope pulley. I had one
Ratchet.
inspector, yeah, like a little rat. It's really cool. Just I had one inspector say, you can't use them. Like, what you got from the manufacturer? So I went back with like chain, like what you would hang like a swing set from or something like that. And that kind of helps take some of that vibration noise out.
Vibration pads underneath the feet
That helps.
can help also.
Yeah. A threaded rod just carries it for some reason.
There's one thing I hope we get to. If not, I just still want to say this.
Of course.
Like, I want to get nerdy again, right? When is the dehum not going to work for you? And it's problematic houses, right? Like, this is trying to, like, I don't want you to think if you buy a dehum, you're going to fix every
No.
house. Because I don't want you calling Nikki complaining and saying, I bought this dehum and it ain't working. You know, like, there's plenty of that. Trust me, I probably did that to you at some point in my career. So here's what I've learned. Like, who has installs with ductwork that's outside the thermal envelope? It's in the vented attic, right? Tons of hands go up. Are you checking for duct leakage that's outside the envelope?
Should be.
You should be. Because here's what I'll tell you. If you have 200 CFM of duct leakage, your dehum will not fix that house.
Right.
If you're in a humid climate, you have 200 CFM of duct leakage, no dehum's going to fix that problem. You're screwed until you fix the duct leakage. Now, you still may need a dehum, but the dehum's not going to be your Band-Aid fix. Why? How do I know that? Because I've done it, and it did not work.
All right, we got a cruise here. Supply to supply. This is a newer one. Andy asked if you were here. Was it last year we had Andy and Ken here up on stage? Andy asked is an engineer here in Florida that we worked with, and he tested this and worked with Hvac to actually test it further and get it into the Florida Building Code. This gives you a supercharge when the air conditioner's running on dehumidification. I will tell you, in a retrofit situation, from the calls that I have fielded that have tried this, on a retro, we have ended up heating up the last couple rooms on that supply duct run when we installed it this way. And really the two major benefits, you don't have static, and then also you're supercharging, but only when the AC's running.
Right.
And again, dehus and AC really shouldn't be running at the same time if we're doing everything correctly. I don't know if I know Brian's not a big fan of this one. We've talked about it, but what about have you
I've never done it. It's interesting. I haven't seen those in the wild, a supply to supply. So you're literally pushing really, really cold air right into the unit. So the whole unit at that point is being exposed to those cold temperatures, right? And I mean, like, it definitely has to be in conditioned space if you're going to pull that card. You're not going to push a supply to supply and throw it in a vented attic, not unless you want the ceiling to fall down eventually.
Right.
Or you put it in a massive stainless steel pan with a drain on it. So things you got to think about.
It's a very specific application that you would use it. Again, the nice thing is you're not getting any losses through ductwork because you're actually pushing the air in it, and you're delivering air to the dehumidifier already at its dew point, so you're not having to bring it down to dew point, which is sort of like energy that could be used towards dehumidification. But in the real world, I'm not a fan.
I think it's interesting. Conceptually, I think it needs to see more in practice so we can prove it out, you know. But like y'all's fin spacing's wider, so you can bring your cold temperature longer, so you can actually pull that card and get more moisture out because you can run such colder temperatures, right? So ideally it should work.
No, it works in theory. It's just there's not an application in sort of doing large commercial that you'll have a successful run at it.
Yep.
Because you just like in Houston, we know what we're connecting into, and even if we're going to sell a duct modification, we're probably not going to sell them a 100-foot trunk line. And so, I like it. I haven't been able to use it. I've got one that I might do it.
So what would you guys choose? Return to return or supply to supply if you had the shot?
If
You don't have that choice. So if you got to pick one, which one do you pick? Supply to supply?
do I have an air handler? Because I'll mix it up with you.
Well, I would sure hope you have in there.
I was thinking about if I had to go return to return or return to supply, I'd go return to return, but I wouldn't pump it to the return. I'd cut a hole in my air handler and put it right to the blower.
Like,
Think about it.
that's the best way.
Think about it.
If you're in a heated, dominating climate, so when you're in the shoulder seasons and you're using heat, you can't use this one because that's usually when dew points are high, but temperatures are low, and you might have some heat going on at the same time. You need dehumidification. So,
If I got a customer who's giving me those two choices, I'm walking away. I don't sell turds.
yeah. What, Kimberly? What are you saying?
Kimberly's giving me the no-go zone, but I'm gonna go
Oh,
there.
avoid your warranty.
Nobody cares about that.
All right. All right. How to size a dehumidifier? I will start with the preface that when you go to our website, you will see that we have dehumidifiers sized by square footage with 8 to 10 foot ceilings. That has been the same recommendations since we invented these in 1996. So not high performance homes, not tight constructions, and we are super conservative on our recommendation of sizing. So, we have a quote unquote 70 pint dehumidifier that we say up to 1,800 square feet. I think some of our competitors say in some climate zones that can go up to 5,000 square feet. We would rather have you have more dehumidification than you need than not enough dehumidification. But is this always the right way to size a dehumidifier? It is not. How many pints are in a square foot? Well, depends on the homeowner, the ventilation,
What altitude?
everything. So Tim recently wrote an article for HVAC school on this, and I think from your guys' perspective,
Very good read.
how are you sizing dehumidifiers? This is on our website. We give you our performance curves on our website. We also have a trifold out there. We think it's very important that you understand how, when I say 70 pints, that's at 80 degrees and 60% relative humidity.
And no ductwork hooked up to it.
Huh?
And no ductwork hooked
And no ductwork.
Right, no
Nope,
static pressure.
Nope. And that's how we used to have to test them.
Yeah.
That's how we were required to test them and report the capacities. It wasn't something we made up. And so all the dehumidifier manufacturers had to do that. Now the DOE came out in 2019 and said, wait a minute, that's not accurate. There's portable dehumidifiers and there's whole house dehumidifiers. Whole house dehumidifiers need to be tested at 73 degrees and 60% relative humidity, and portables need to be tested at 65 degrees and 60% relative humidity because basements and crawl spaces are usually cooler. What you will find is the 70 pint ducted unit goes down to 55 pints at 73 degrees and 60% relative humidity. That's you just lost 15 pints just based on temperature alone, not even static. And when you put that into a crawl space, I think we have it at our table out there, but I think we're going down to like 45 pints when you go to 65 degrees. So you need to know your application and the amount of latent that you are counting on these dehumidifiers to remove in order to be able to make sure you're getting the right unit for the job.
Yeah, and then ductwork and static pressure derates them also. So like the 70 pint with no static pressure is 150 CFMs with 0.4 inches static, which is not bad, right? It goes down to 130. But then the larger models have a pretty significant drop off. So you can look at a total heat formula, latent heat formula, whatever. Airflow is 1/3 of that formula. And when you lose your airflow, you're derating that dehumidifier even more. So just like we would not, please tell me you're not still standing at the corner of the street looking at the house and saying, well, that's a 2-ton, that's a 3-ton, that's a 4. We don't size units that way. We don't need to be sizing dehumidifiers for square foot either. There's some simple math to do that and do so accurately.
Yeah.
Hey, Nikki, is the crawl space 105, is it still with that
what design temperatures they have you in the set?
So that has been tested at the DOE whole house and at the crawl space. So that's 6560. So if you go on the DOE website and pull up our units, you'll see which ones have been whole house. I mean, our Ultra 70 has been tested at crawl space, basement, portable conditions as well, because sometimes they get put into a crawl space because someone wants to wire a float switch, and that has a terminal block where the compact 70 doesn't have a terminal block on it. So, but yeah, all the portable units are at 6560. We want you to be successful, so we are very transparent in what we can deliver at those different temps. And I even have a chart on when you add static to these units, how that's going to affect their capacities as well, because you need to know that.
I don't know of any other manufacturer that is giving their numbers at our design conditions, which is 75 dry bulb, 50 to 55% RH, because dehumidifier manufacturers don't have to publish that. They do because they want us to be successful.
I get making sure that we want to make sure to, instead of the oversized, you need to make sure we have enough dehumidification, like you said, but can you oversize it?
Oh, God.
Yeah, you can.
Short of selling a customer something they don't need, just selling a bigger, more expensive unit, what other problems
Yep.
come about?
Yep. If you
Oh, yeah.
can you oversize a dehumidifier
oversize-
too
Can you
much?
oversize it?
Yeah.
So one thing, if a dehumidifier short cycles, same thing happens when an air conditioner short cycles. The first few minutes of that cycle, you're not doing any latent removal because you're trying to bring that coil down to dew point, right? So you're just wasting energy at that point. You're making heat, so you're adding load to the house, congratulations, but you haven't done anything about the moisture yet for the first few minutes. Then when it shuts off, if your fan's still running, guess what? A little bit of that moisture, it's not much, but it's a little bit from that dehumidifier goes back. So really, on a peak dehumidification day, or when we're sizing these things for whatever that condition is, it should not be your design day. Your air conditioner should be able to handle all your latent load on your manual J design day. But when we're talking about part load operation, we want the dehumidifier to run. Let the big dog eat. We don't want it to cycle on and off because of those situations. And just remember, they do put out heat. There's a conversation, how much is that? Does it really affect you? We can go around and around on it, but they do put out heat. So just keep that in mind, that you don't be blasting heat on somebody unnecessarily.
And we will tell you that the heat, the temp going into that dehumidifier and the temp coming out, there's going to be about a 15 to 20 degree difference in the heat coming out of that unit. So that's, it. Again, we're going into that supply duct work. Hopefully, we're mixing, but you got to be careful. You got to be careful with it. Now, we're going to have to cruise here a little, but make sure we do have links at the end of this with lots of resources. But Ken Gehring and Andy Ask, when they were here last year, Ken did tackle oversizing as well in that presentation. So if you can go back and look at that one, that's a really good one. We talked about ventilation. Why sell dehumidifiers? I mean,
Comfort.
Yeah. Because it's a responsible way to ventilate the house in a green grass climate. What other options do you have? Turn on the fart fans? No, don't do that. Bring in hot, humid air into the return plenum. You're going to own a mold case if you do. This is the best way. If we're going to ventilate a house, if we're going to go there, let's filter the air and dry the air before we deliver it, before it ever even hits the house. That's the responsible way of doing it. I just wanted to make one comment about the size of the ventilation duct. They put 6-inch collars on these. Don't think that you're tied to a 6-inch duct. The 6-inch duct is only going to move. A lot of factors go into it, but in my experience, 20 to 35 CFMs, that's about it. Most houses need a little bit more than that. So you can step up.
On the 70 pint?
On the 70 pint.
On the 70 pint?
Yeah, so just remember that you don't have to stay a 6-inch. So you can step it up to an 8, a 10, even a 12. You're tied to that little 6-inch collar there, but don't stay with it if you really need to move more air than 20 or 30 CFMs.
I'll make a comment on why to sell a dehum. So I didn't do the math. If you want to hear the math, my boss Steve over there can do this math. He's above me. But we were talking about this last night. And there's brands out there that'll run resistance heat and use that strategy for dehumidification. So Steve ran some numbers, and he said if you ran a dehum, and then you, as one strategy, and then you compare that to resistance heat running to get the same dehumidification at AHRI conditions on both, you will pay the magnitude of 3 to 5 times more to run the resistance heat to do the same work. So it's significantly less expensive to run the dehum to dehumidify over the resistance heat. Now, short-term strategy, you know, I mean, people have their choices, but if you're playing the long game, you want to do the right thing for that customer, I think the dehum is the way to go.
Jenry made a good point. He's like, sure, try reheat dehumidification. That's fine. If we can't, if you can't afford one now, or you're on the fence whether this is going to help you, go ahead and do it. But you're going to pay more in power bill, and once that starts hurting, let's talk about dehumidifier.
Yeah, my multifamily world, it's all about property protection. So my client is the owner, the developer, the property manager, and it's all about property protection. And they don't know which clients are coming in, who's coming in with a 1-year lease. So we harp a lot on the property protection piece, and you don't know what they're doing in there and all that kind of stuff. And in my neck of the woods in Northern Virginia, they've learned their lessons from continuous running exhaust fans and stuff like that. It just does not work. So we push property protection a lot because it's the only way that they can actually have control, and a lot of them can monitor the humidity in the space. So a lot of them are starting to put in so that they can watch the monitor in each one and make sure no one's shutting it off. And that's when my clients are buying, it's because of that, because they're afraid of what's going on in the units, and that's the only way they can control it.
Dustin, how do you sell it to a homeowner?
Comfort, health. I mean, so really just let them buy it. You don't have to sell them anything. They have the problem, and they're the one with it. It's not yours to own. It's yours to solve, and yours to help, navigate them through. Just navigate them. The problem's there. Address it. Provide them a solution. Let them know that you're the guy to help them figure it out. And you got to succeed, though. Like, that's an important part, because for you to become the I could have swore that was up there. Anyways, the local hero, the one that everybody goes to, is you got to succeed at this. I mean, like, pay attention to it. Don't just willy-nilly throw one in. But they buy. They're buying them right now. And you have to also change your perception of people don't spend money. They do. Look around. They buy all kinds of stupid stuff. They definitely want to buy for their comfort.
We're getting tight on time here, but we got a list of resources here. Tim's article's in here. Jenry's case study that we worked with them on. There's some podcasts. So when you go online to rewatch this session here, because it was so entertaining, and find out more about Chris in his closet.
I'm staying at the same house with him.
Oh, gee.
Do what?
Yeah.
And then if you want to get in touch with any of us, here's our LinkedIn and our Instagram, and all of us are happy to help and answer any questions the rest of the day or at any time as well. But again, those are all linkable and clickable on the HVAC school site with all the presentations.
And come talk to us.
Yeah.
And if you don't want to come talk to us, then reach out to us online. But if you have a question, don't be scared to ask it. We all have questions.
And honestly, I'll reiterate the links. There is some solid links right there. Don't think that's not valuable. We put a lot of thought behind what we wanted to post
The
in those links.
resources?
Yes.
Yeah.
Go to the
You can
ASHRAE
see
website.
I don't have a link
Look at the
underneath my
mean
name.
coincident wet bulb in your area. Pay attention to that.
Yeah.
All right, thank you.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.